Alright, we're going to learn how to do the Lewis structures of dithionate and dithionite. Dithionate is S2O6 with a -2 charge. Dithionite is S2O4 with a -2 charge. There are 2 sulfur atoms and 6 oxygen atoms, so what we're doing here is the accounting of the number of valence electrons. Sulfur and oxygen are both chalcogens, so they both have 6 valence electrons. The times 2 and the times 6 signifies how many of the atoms are there. Then there's a -2 charge, so we add an extra 2 electrons. The total number of electrons is 8 times 6, which is 48, plus the 2. So 50 electrons have to be accounted for in the Lewis structure of dithionate. So we'll start by drawing the sulfur atoms connected to each other, and then all the other 6 oxygen atoms bound to the sulfur atoms. And dithionate, it says, is actually used as a detector for radiation, because when gamma radiation hits the molecule, it actually breaks the molecule into 2 radicals, and then they can use it to, by the amount of the radical present, they can detect how much radiation the person's been exposed to. So it's been proposed as a reagent being used for detection of people being exposed to radiation on their detection badges, their dosimeters. Anyway, the lone pairs here, if you draw it this way, you have 6 negative charges on the oxygen atom and 2 plus 2s on the sulfur. That's obviously completely untenable. You can't have 2 positive charges right next close to each other like that. So if you move in 4 lone pairs, you get double bonds all the way across here, and you still have the 2 negative charges on the oxygen atoms. The sulfur will have expanded octets, but each sulfur atom is in possession of only 6 electrons, because remember, when we count the charges, the bonds only count for 1. So we have 2, 4, 6 electrons being possessed by that sulfur atom. Same thing for the other one. And then we could argue also that these double bonds are shared, these 5 bonds are shared over 3 positions. Now, I don't know if there's any double bond character between the sulfur atoms, and my guess is no, because there's more electronegative atoms on the outside of the molecule, so they would probably pull the electrons outwards. For dithionite, it's a similar setup. We have 6 electrons per sulfur atom, 2 atoms of sulfur, 6 valence electrons for oxygen, with 4 oxygen atoms, plus the 2 extra electrons for the -2 charge. So 38 electrons have to be accounted for. You would draw the sulfur connected to the other sulfur, and then the 2 oxygen atoms on each of the sulfur atoms. We start off by drawing it symmetrically. That's usually a good bet. Then, if we draw it with the preliminary structure, we're going to have a whole bunch of formal charges, because we'll see that when you put 3 lone pairs on the oxygen and a bonding pair, it's going to have possession of 7 electrons. That's why each oxygen has a negative charge of 1, although the octet requirement is fulfilled. Same with the octet requirement on all the sulfur atoms. There are 8 electrons around the sulfur atoms because of the lone pair and the 3 bonding pairs. But the sulfur atoms are only in possession of 5 atoms. When you count for charge, you'll see that it's 2, 3, 4, 5. Sulfur wants to have 6. So in fact, each of the sulfur atoms has a plus charge when drawn that way. The way we can remedy this Lewis structure is by moving 2 lone pairs to make them into bonding pairs. So it gives some double bond character to the sulfur and oxygen atom. And you'll have an expanded octet, but now the sulfur atom has possession of 6 electrons. This oxygen atom has no charge, and now the 2 negative charges are still there, which is what it would be normal for dithionite. So that would be a good structure for dithionite.